Thank you. I must congratulate the organisers. In a way, we are following on from the previous previous speaker, because it is also is online education. And as Kim said, the title is intriguing. Obviously, if we dissect it, experiment, well, everybody knows what that is. And the glass onion, I could explain that to you as well. However, I think I'll leave it to Lennon and McCartney to set the scene. Of course, I don't have to point out to you that's a nearly 60-year-old prediction, and it does not have to be a wearable entity, because a couple of weeks ago, there was the glass onion, the flat glass onion. The Pokemon Go is in fact an implementation of augmented reality as a game, but still augmented reality. This is going to be a presentation in 5 parts. I'll be doing the first 2, Aaron, my colleague, the next 2, and then I'll hopefully wrap it up and point to the direction where I think this is heading. Kikan-shido is the first topic of introduction to you, and this I credit to the ICCR, which is the International Centre for Classroom Research at the University of Melbourne. And it's basically a Japanese term meaning between desks and instruction. It comes from a comparative study which was carried out for year mathematics and science classes. And as you can see, there's a summary of these kikan-shido activities. Now, why I start at that point is, as Kim said, our interest is in experimental experiential learning. And of course, while the students are doing their maths work in a class, it is actually experiential experimental learning. And so the supervision that's carried out by the teachers, I felt, was representative of what we do in lab classes. And of course, experimental learning is a very important part of engineering education, or in fact, further than that, STEM education. And of course, online providers of STEM education will find that that is probably the greatest hurdle that they'll need to get over. The second part of this journey is my PhD thesis, which I did about 10 years ago. And it tried to bring the that kikan-shido, the classroom experience, and see if it's also present in tertiary institutions. And the idea was to try to mimic face-to-face supervision using a kikan-shido-like supervision, and have that somehow mimicked over a screen-based experiential learning to which the supervisor is connected by a local area network. And to sort of bring it into tertiary environment, I tried to tie together what I thought, what I have practiced over the years when I was supervising students, and that's over-the-shoulder learning and teaching. I suppose it's a bit like on-the-job training. And I try to take those 2 different types of pedagogy and tie them together, as you can see in that particular diagram. The activity that I examined was an on-screen activity, and that sort of had limitations, if you like, because a lot of engineering type work and pracs aren't necessarily on screen. And for that activity, I suppose that activity was in a way restrictive. However, it did, as you'll see a quick demonstration of it, it did sort of highlight that with the setup that we had, where the academic was more or less, if you like, virtually walking around the students while they were behind the students while they're working, and then the connection that we established using this software called Net Support School, we were able to effectively mimic what happens in a face-to-face environment. This is the lab which my experiment was carried out. Probably not the right term, not politically correct when you're dealing with students. And of course, the building has now disappeared because the ATC is in its place. Two pieces of software used. One is Net Support School, which allowed me the communication, and the other one was Electronic Workbench, which is a circuit simulation software. And the students were carrying out, as you'll see here, an exercise which basically was to simulate a circuit. This is the academics view. And you can see that it's a bit like walking around.
Okay, I'll tell you what you're doing, and if you need some help, I'll try to show you what to do. So
that's the circuit that they needed to simulate, and with this software, I could actually monitor their activity. I could make a connection and communicate with them, and actually take control of their computer and help them. Just watch.
Matthew. Yep. What have you got 5 seconds, half a second or something under your switches? Where'd that come from? All right, well, can you just go to one of the switches and click on it from the half a second? Show me what it looks like. Double click on it. It's a delay switch. You picked the wrong switch. Can you get rid of those switches? Well, that will get done. And let me just show you where to find it. I think it should be under the resistor block here.
So just like standing next to them or behind them, and of course they can actually look over my shoulder while I'm actually demonstrating to them. So it's very much like what would happen in the real face-to-face environment. Over to Aaron.
Thanks, George. Well, that's all well and good, but we wanted to know really how the students learn, not how they're directed to take action. So one way of looking at how they learn really is to try to analyse their interactions amongst themselves, with the tutor, as a group or individually. And we applied, in fact, to get some funding for this, and the government was kind enough to give us a few pennies to try to implement this. And if I can just move forward. We looked at face-to-face learning, and we wanted to find out, in fact, what the environment was like, effective the students' learning, and how they actually used the environment itself for their learning. And you can see there in the small photographs where the laboratory was. And we thought of developing a framework that other people could use as well to try to analyse how students actually learn. And we wanted to collect data and analyse actually the words they used and their interactions. And this could be applied really in any experimental environment. And the reason I got involved is I'm not an electrical engineer like George. Here's the bright spark. I just make and break things. I'm a materials engineer, but I also build things and I take them apart. So the idea was we look at two different experimental situations and see if we can compare how students communicate, how they learn in slightly different environments. George is perhaps a little more virtual because the students can't always see what they're putting together. In my case, of course, students actually build things physically and photograph it. And we'll get to that part later on. So the framework is really like a template. And it looks really at what the deficiencies are in any venue or the positive aspects of the venue to try and improve the experimental experience. It either works in a definitive brick and mortar environment, or if people are trying to design a new laboratory, how they can incorporate this into their new laboratory to get the outcome and the learning experience. We developed this and actually have set up a website which is available at Swinburne, and using modern technology, which is now old, of course. TuteCast is about 10, 15 years old. We've run workshops and master classes about this. And
Swinburne really University of Technology.
What it's all about, how we acquired the data.
Hi, my name is Martin, and today I'm going to show you the work that we conducted for the OTST project. We're going to show you the equipment, and we're going to show you the workflow that we used. The most important piece of equipment for this research were the video glasses. This allowed us to get a personal view of the interaction taking place. Through an iterative process, these glasses were chosen because they provided the best solution for this research. Other technology was trialled, such as GoPro type cameras on head straps and helmets. However, these were too intrusive. Care for selection of the SD card is imperative because too small a card will result in limited footage.
So students wore these
The
glasses.
card that we chose was 16 gig, and it resulted in a recording time of about an hour and a half, which was actually quite good because it matched the amount of time that the batteries lasted on these glasses.
So this set up the basis, in fact, to do some more work. We published a few papers out of this, and it was well accepted by the engineering education community that we applied for some money from Swinburne, and they were kind enough to give us a few more pennies to do some work. And we looked at how we can explore the use of these wearable technologies for real-time supervision via the internet. So students could be anywhere, literally, out of space on Earth, as long as there's GPS or there's a LAN connection, they can do this work with supervision. And we trialled it out first in a very simple experiment in the first year electronics, looking at working out capacitor values from different circuit calculations. And we call this augmented reality, an assistant to reality. And this shows you the outline of the lab and where the glasses are actually located. It looks fairly basic, but of course we have the screen up the top which helps students work out what they are. So students would communicate with each other and with the supervisor or via the gear that they were wearing at the time. So how does this compare to a real hands-on environment? Well, we looked at the so-called interaction with the students, and we tried to look at about 14 to 16 different comparative situations, everything from monitoring what's going on, to the tutor guiding students, to, in fact, the social interaction, and to what actually the students get out of the situation. So it's fairly detailed, and this was done by analyzing recordings of interaction of audible conversations. That's all it was really, and what was called gesturing, and that was the important part where the tutor would gesture. So we cut this down into 4 major groups called audible, visual, and gestural, 3 groups, and then into situations where they interacted amongst each other, with the tutor, with groups, and try to analyze the different interactions and try and say what is common amongst all these that could be an aid for student learning. And we found this occurred in many situations, and we're going to put this into a framework. This is a very simple demonstration of what the framework would look like, but I'll cut it short again. George will start it for me, because he knows how to turn the switch on. So that's the tutor talking to the students, what the students see. This is, in fact, where the gesturing occurring in that little rectangle there. So the tutor is far away, totally separated. The students are then, in fact, in a similar environment, in an augmented reality environment. So essentially the tutor appeared to be with the students to give them this same learning experience. So what does that mean for us?
All right, well, where do we go from here? And I know I've got a minute to do that, so it's going to be very quick videos as well as some predictions. The first, this is just a thought-provoking demonstration which was funded by Microsoft. It's carried out at Case Western University. Obviously, as it is, it's sort of Lunig's way of distance education. You can see it, you can recreate it, you can give the students a visual experience, but is that what it's all about? And the answer, we think, is not. And obviously, the answer is that it needs both the visual as well as a haptic feedback as well. Now, you saw an example of this glove. So where to? Well, we predict that it will be a mixed reality with haptic feedback, and obviously that's where the future goes. Augmented reality, where things are nearly nothing is real, or if you mix the haptic device added to virtual reality, well, nothing is actually going to be real. Thank you.
Thank you.
Thank you for the interesting presentation. I was trying to look at the glasses. Which company did you get it from? Who provided, and what were the capabilities of the glasses?
Okay, obviously things are happening so quickly to some extent that first slide with John Lennon highlights 5 glasses that were developed, and some of them have already died. The glasses we ended up was produced by a company called Meta, M-E-T-A. Since we got those glasses, they've already released Meta 2, which is more super duper and lighter. Its capabilities, well, they told us by email that they can do what we wanted, which was that what we wanted to be able to see the student working on their benches. We then wanted to use the augmented part of the glasses to be able to point to them in an augmented way, and they said, no problems. Then we received it. There was no software with it, of course, to do that, so we had to have it developed as part of that grant. And you might have seen in that clip that there is a little red rectangle inside the main image, and that was the size of the augmented area, which meant that we could only point in that part. My understanding is the new glasses have got a much wider augmented area. So in theory, or ideally, we'd like the whole glass to be augmented, and we should be able to point anywhere in that field.
Oh, great, thank you. I used to teach chemistry, and I'm just wondering what the OH&S is for augmented reality. We've already seen people get into trouble with Google, so I'm just imagining our students gloving up and so on, and yes.
Yeah, well, obviously everything can be used for good or for evil. Now, let's look at the good part of it. If you're talking about things like occupational health and safety, the idea, of course, for those dangerous experiments is to have virtual reality with some sort of haptic feedback if that's required. Now, as Aaron said, I teach in electronics. The augmented glasses, as we saw in that experiment, was actually an electronics lab, was useful. In the case of having a haptic device, to actually have the real equipment, the cathode oscilloscope, the resistors, the capacitor, having that totally virtual is neither here nor there. But in the case of, say, metallurgy or materials, which Aaron teaches in, then touch and feel is important. You saw that clip from that is funded by Microsoft. Medicine is an area where this is absolutely, sort of going to be the driver for everything else. So it's horses for courses. Now, it's chemistry. I would suggest in chemistry you could still provide them with augmented or a totally virtual experiment, provide them with some sort of haptic gloves. And by the way, I'm not here to publicize Aldi, but I believe on Saturday Aldi is selling a holder, or if you like, where you can put a phone for $30, not the phone, but the actual holder that you can clip onto your head, and you'll be able to have virtual reality apps, which I did a quick scan on the App Store, and they're already available. So for $30, including, and then obviously with your phone, you've got augmented reality, virtual reality, So it's not that the equipment is cheap, and it's going to be even cheaper.
And if you saw the catalogue, so you could buy a 3D printer, in fact, to develop an unreal real image to look at through your glasses.